So let us start. We have different organic waste types of renewable carbon and fuel production. Solid waste. All of you know, we generate solid waste every day at home and office, everywhere we do that. And many of those waste are organic or metals. We cannot separate here. Let's see if we can separate at certain facility. Then we have organic waste such as a different lines of fuel and metals which can go to recycling. So there are many concepts. You can say that organic waste, bio-waste recycling system, you can go heat. Heat is the easiest thing to make. If you have organic waste, you just burn it and you will get heat, make it steam. That's the easiest one. But it's a low efficiency, low value thing. It does not have fuel, that's a high value. You make carbon, that's a higher value. Okay, so bio-waste recycling will get heat. Non-organic waste can go for recycling. Non-recyclable waste goes for landfill, and you know landfill issue, right? So you don't want to put a lot of organics there. Metals, glass, paper, plastic can be sorted out and recycled. So the major challenge is we get everything mixed, how to separate. Once we know that, the second challenge comes. We have a tangible feedstock which has a different property. Let's say organic. Organic waste doesn't mean it may have paper, it may have fruits, it may have vegetables and many other things. So that's a mixed feedstock. Supermarket organic, there's all these things. So how can we do this separation? And then, so the property matters, and that's where I left yesterday. There are many different pathways. Will come that you can use biological platform, biochemical platform. You can use thermal platform. So both are commercial processes. Biochemical, what are the things commercially we produce biochemical way? Can you tell? Using biochemical platform like fermentation and all, what we produce commercially, biogas, alright? Even penicillin, pharmaceutical things, alright? So we know how it operates. Only thing for feedstock like this, how to tune that. Thermochemically, how many processes do you know thermochemically? What we do? What we produce thermochemically? Thermochemical means temperature, pressure, catalyst. Most of the product you see around thermochemically, because that's how we learn. Microbe, we learn over the time, last 60, 70, 100 years. But thermochemically, we know for a long time. The best example is refineries. Right? Oil refineries, thermochemical. They use temperature for distillation, they use catalyst, and they use certain times pressure for hydrogenation. So what we are looking at, can we take biochemical route, or can we take thermochemical route to make products, or can we hybrid, part of it is bio, part of it is thermal. So these are the pathways that you can see that this one is given biomethanol how to make. This one is the renewable methanol you can make using electrolysis and catalytic methods. This again we talked, so I will tell you how you get. So importance of organic waste valorization. Valorization is making product, trading out of it, how you add value. A lot of waste. Is there any question of environmental benefit? If you take organic waste and I say let's valorize, that means it has environmental benefits. Right? There is no question, doubt about that. It's going to help. Then it has economic opportunities. What economic opportunity it has? Can you help me? You are making product out of it, so definitely you are getting some revenue out of it. It's a business model. What other things you get? Yeah. Yeah, that's perfect. Yeah. Job creation. For job, we go to Delhi, Mumbai, and all. Right? Now you can have job creation next to your city or town. they are renewable energy. This kind of setup is called distributed system. Can get the rural economy can get stability. Alright. So economic opportunity creates value to a system, supports green jobs and industries. This one we talk how is a circular thing. Petroleum fuel and biofuel, how they are different. I don't want to do those. Yeah, this one we are talking. So biomass conversion technology can have a biochemical or thermochemical. When we talk biochemical, what's the benefit of biochemicals? What advantage biochemical has and what challenges biochemical has? Come on, from biochemical side, who is already working. How you tell refineries that let's do biochemical way, it's better. So what better you say?
External energy.
So it's a low temperature. Alright, that's what this one of the most important advantages of biochemical. What are the benefits? Easier to operate once you know that you don't need a whole lot of complex systems you have. What's the challenges? Maintaining optimal conditions. Right? How far? Yeah, inhibitor and also typical maintain culture, it may crash and everything goes back. Alright, so that's a complexity. How fast it is? 24-hour fermentation is common, am I right? 12 hour, 24, 36 hours is common. So to get a product from beginning to the start, you need to wait a day. Am I right? So that's a challenge. Then the thermochemical person will come, a professional will come industry. We make products in half an hour, 30 minutes, 20 minutes, 1 hour, 4 hours, not more than that. Have you seen any product that thermochemically coming in a day, 72 hours? No. So that's their benefit. The challenge is high energy requirement. So pay for energy, temperature, pressure, so equipment or material cost is bigger. Alright, so you need high temperature materials. So that's the major difference which one you choose. Okay, but you cannot plan everything for thermochemical, you cannot plan all the products in good probability. So it depends on what feedstock, what conditions you want to run and where you want to operate. Knowledge base is in both sectors. Fermentation has been century old, how to do fermentation. Okay? Thermochemical, again 100-year-old or more, alright? There are big refineries, they know that. So if you are a refinery guy, let's say Reliance or HPCL or someone, and there you want to sell your biochemical process to them, that is outside their comfort zone, alright? So they may have a big for R&D and all, but when it comes to commercialization, they may acquire some form instead of being your own. Same thing for biochemically. They will not try to go to other side because that's the comfort zone. So that's where the challenges comes. So thermochemically, it's a combustion is the easiest thing to do. You burn it, get heat, make a steam and do that, but that's not efficient way of doing that. You don't make product, you make heat. Heat has low value. If you look at thermodynamically, heat is high entropy. High entropy is a low value. Okay. Pyrolysis you can do, then different products for pyrolysis I will be talking down the line. You can do gasification. You can gasify again different products. I will talk down the line. So these three you can do. Biochemically we can do anaerobic digestion, biogas production, or alcohol, ethanol, methanol we can do. Even dark fermentation for hydrogen and other things we can do. How bioethanol will come down later. Biodiesel. How biodiesel is made? Anyone? So diesel is longer chain than petrol. If you look at the chain length of carbon, diesel is 14, 15, 16, petrol is C7, C8, 8, so shorter chain. So if you are looking at diesel, vegetable oil, waste cooking oil, grease, they are a good source of, because they have long chain fatty acids. So take long chain fatty acids, use with some caustic sodium hydroxide or tablets and ethanol, and this process is called trans-esterification, and that's how we make biodiesel. So it's a very similar to, it's not high temperature process, 60 degrees or something like that, and you can do that. Okay? It's very similar to alcohol production, beer, fermentation. So it's not big deal. You have a sugar, you can ferment, get beer, alcohol, these things. Biodiesel, you can get it. Okay. The challenge is, do we want to put vegetable oil for making biodiesel? No. We don't want to pay more for Coca-Cola or mustard oil, am I right? That will go there. Waste cooking oil can be, and there are many seeds which we don't use for. Those seeds can go. Now, biodiesel and ethanol is a blend fuel. Understand, blend fuel means you blend it. 100% not there. Means you cannot fill 100% ethanol, no gasoline and run in your own car. No. Then you have to change engine and everything. So that's not dropping fuel. Same thing for diesel. Biodiesel is not dropping fuel. It is a blend fuel. You can blend 20%, 10% diesel fuel and other things. So the concept for future is, first, don't use vegetable oil. Use non-vegetable oil, which is not. For ethanol, don't use a starch. Use lignocellulosic, what I was talking yesterday. Those are advanced generation. And now more traction is going on more than ethanol. Get direct petrol from cellulosic. Or take ethanol and upgrade to petrol. Okay? Because ethanol is not dropping. And everyone looking for 100%. We don't want to change. A car company will say will not change the engine. It takes a lot of things. Same thing for biodiesel. The focus is gone. Biodiesel we learn how to make. It's a blend fuel. But if you want to be more, look for dropping fuel. So that is called renewable diesel. Okay, and I'll talk about that. So that is dropping, and you can make it. But that is not trans-esterification process. That is hydrogenation process. And again I will talk. So that's the difference. And here you see micro-LD sitting here. Micro-LD can be used for. So I have a full talk on micro-LD, will go there. But micro-LD contains oil. So that oil you can take it and make trans-esterification, you can do biodiesel. Again I say biodiesel and ethanol are first generation mostly. We are looking for dropping fuel where we don't have to change our infrastructure. The refineries, they know how to take and run through the refineries. Pyrolysis, when we do biomass pyrolysis, you get three products: gas, oil and charge. Okay? Gasification, we get syngas, and we can make syngas to hydrogen. So again, I have separate talk on gasification. These are this. Another process is called hydrothermal liquefaction or hydrothermal process. That's where my research mostly I have worked in fact my PhD on that. So what is hydrothermal? What is the major challenge of food waste or LG or this kind of thing? We have a lot of water. And now we say do pyrolysis. Doing pyrolysis of water is to make a steam and then little bit of fuel. So the solution is to remove water and then do pyrolysis. That becomes energy intensive. So can we do that chemistry using presence of water? We say don't remove water and do thermal process. So it's called hydrothermal, where water becomes green solvent. It's kind of ethanol, act like ethanol, and and it can be green solvent. So again, I will go more detail, but you can use hydrothermal process and you can make charged acetone water soluble biocrude. So biocrude is more like a crude. MSW and all, industrial organic waste, these are more common. So waste to fuel technology, anaerobic digestion, biogas, fermentation, ethanol, pyrolysis, biochar, bio-oil, gasification is syngas, synthetic gas. Again, we will talk about that. Biodiesel is transesterification process and